Hello students and welcome to another video. Today we're going to be talking about level 3 carbon and ecosystems. So now we're going to be looking at just an example of an element. Okay, you can find these elements on the periodic table. It's up on my wall. You can see it up there. It's number 6 on the table. And we're going to think about how carbon is cycled within the within an ecosystem. Now, we've built up a bunch of vocabulary and understanding and from days 1, 2, and 3. So please go back and do levels 1 and 2 if you haven't done that, because some of these concepts are going to be pulling in information from those previous levels. All right, so I want you to go watch this video. This is a phenomenon. It's introduced this idea to you, and it says, what if there were 1 trillion more trees? What would happen to our environment if we planted more trees? This is a fascinating video. It talks about how trees act as vaults. Right, a vault is like a storage place that's secure, and what it's doing is it's securing carbon from the atmosphere. And like, why would we want to do that? And would planting trees solve the problem? You know, those kind of things. All right, after you're done with that, I'd like you to work on the textbook reading and go read these pages here and then answer these 3 vocab words. All right, now I know there's like 6 pages here and there's only 3 vocab words, but please read through the chapter, become a little familiar with the information that's in there. Don't just go ahead and define the words and jump to the next thing, okay? Because I do have questions for you. Like, why is it important to living organisms that nutrients are cycled? Like, why do we need to have cycling of nutrients? Giving an example of how carbon is cycled in nature. So give me an example of it. So think about how carbon moves through it. There's a whole page on it. So please read it and give me an example of how carbon moves through nature. And if you need to, give me like 2, actually, no, I'll say 2. I'll say 3 or 4 steps, like how carbon moves from place to place to place and how it transforms, okay? So just map it out for me if you need to, okay? I'm just quickly scribbling here. So, yeah, just map it out for me. Show me how carbon moves through an ecosystem, okay? All right, now, down below, let's spend some time and actually focus on it more broadly, looking at the different spheres, right? Day 1, we talked about this, the different spheres. All right, so here we have the atmosphere. Let's go back and let's review a little bit. So we have the atmosphere. We have the geosphere. It's not on here, but it's down here in this section down here underneath the ground. Actually, in this drawing, it's kind of 3-dimensional. It's right down here. There's your geosphere. The biosphere is where all these living organisms are, and then the hydrosphere is where the ocean is. It's right here. That's our example. So those are our spheres. I'll just erase those to open this back up. Now, what we need to do is I'd actually like you to write these things out and become familiar with these terms, because when I talk about them in the image, you'll have some ideas, okay? So in the atmosphere, it comes in this image, there's 3 common varieties. We have CO2, carbon, and CH4. And these are the names of these molecules. So a molecule is groups of atoms. So we actually have 3 atoms because there's 2 oxygens here. And then there's 4 hydrogens and 1 carbon, so there's 5 atoms here. This is known as methane, or also known as natural gas. C is just elemental carbon, as we would find it on the periodic table. And then with CO2 is carbon dioxide. So di means 2, referring to 2 oxygens. All right, we have emissions, respiration, breathing, and photosynthesis. These are the common ways in which we see carbon cycled in the atmosphere. Like, for example, respiration, right here, this section. You are breathing right now. You are engaging with carbon by eating the sugars, and then your body breaks them down. And when you breathe out carbon dioxide. That carbon dioxide is being released in the atmosphere. Okay, and the plants take that carbon dioxide and make those sugars for you to eat again. It's being recycled. So photosynthesis. And then emissions occur when elements from the ground, like fossil fuels, like oil or coal, and we burn them and we use them to heat things up and do work. Right, we call that emissions, and carbon's being released into the atmosphere. Right, whenever you're driving like behind a big diesel truck and you see all that black coal coming out of the exhaust, what you're seeing is a bunch of that black smoke is elemental carbon just going into the atmosphere, and it disappears quickly because it dissolves within the air. The particles become so small you can't see them anymore. The clumps break down into small, fine particles that are not visible to the human eye because atoms are extremely small. And if you want to know more about that, we will talk about that in my chemistry class if you want to come take that from me next year. So then here we have the hydrosphere. We have carbon again. And then we also have CO3. This is carbonate. All right. It's a little more complicated than this, but I'm just going to give you the simplified version. It's carbon with 3 oxygens, and we call it carbonate. And it's what makes up seashells. The seashells are made of carbonate. Okay. They don't dissolve, and the special thing with carbonate is it forms compounds that don't dissolve in water. Now, if you're in the ocean, what do you not want dissolving? Your seashells. You want to have substances that are not soluble, that don't dissolve in water. So if you look on my shelf, I have a whole bunch of seashells. You guys can look at them, and they all are made out of calcium carbonate, and they're all built using that molecule to build all of their shells and structures within those organisms. Okay, in the geosphere, we typically just see it as carbon. Okay, and this is coal, and we use it to build buildings and to power buildings and getting from place to place. Energy is everywhere. We need energy to power our lives. And as you get older and you're in the world longer, you realize there's a big battle going on for energy. Where are we getting our energy from? Is it clean energy? Are we having safe mining practices? Are mines blowing up? Are we fracking and causing massive incidents? Are we collecting things in a sustainable way? Are we destroying habitats, right? And so the geosphere is often very involved in providing energy for humans and for our daily lives. And we typically burn this stuff through combustion, which like your car or your furnace, right? Burning natural gas or burning gasoline, and it releases carbon into the atmosphere, okay? And it's just elemental carbon, because if you see coal, it's black. That's just pure carbon. That's what it is. Black oil is basically pure carbon because it's a black substance. Carbon is black when it's in elemental form. Typically, it does come in different variations, but that's the simple definition. The biosphere. Carbon is the building block of all living things. Now, what makes carbon so special is carbon. I'm going to draw these lines around it. They want to bond to things, all right? So let's just say A, B, C, and I won't see. All right, D. Doesn't matter. So carbon can bond to multiple things. It's like the ultimate Lego piece. It can bond to something over here, 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 and there. It can connect to things and build long chains and make rings, and it's just the ultimate building block. So carbon is just the backbone of all living things. It's the Lego piece that is the most useful to like build these big complex structures. And in biology, we call them macromolecules, and we'll talk more about them in the biochemistry unit. So that's your kind of main idea. The carbon is found in all kinds of different forms, but it's just a building block. That's how I want you to think of it. So this is where we find this is our common things. Now bring it up here, and I want you to color it based on what sphere it's in. So if it's in the atmosphere, I use light blue. We have carbon dioxide. We have elemental carbon. We've got it here. Okay, CO2 over here. So buildings are giving off carbon dioxide because they're burning our fossil fuels. People are breathing out CO2 because they're going through respiration, right? Our plants are intaking it. They're taking it in. You can see how these crops are taking it in. All right, and then the last one is CH4. All right, we have methane from our farting and burping cows. There's actually big dilemmas going on because people are like, there's too many cows because they're releasing too many emissions. All right, there's people that argue that we have too much livestock because they release CH4. Now, CH4 is actually very, if you release it into the atmosphere, it's more of a greenhouse gas than CO2 is, than carbon dioxide, because its greenhouse effect, or the magnification of what it can do in the atmosphere, is much, much, much greater than carbon dioxide. So for every like one molecule of CH4, it's like thousands of CO2s. Like, it's just dangerous. So whenever you're like by an oil field and you see a little flame burning, what they're doing is they're burning this CH4 and turning it into other things, because releasing CH4 right into the atmosphere is bad for the environment. We don't want to release tons of CH4. Okay, let me back up and erase all this. Okay, that's the atmosphere. Now, let's work on the hydrosphere. So the hydrosphere is really simple. It's just right here in this image. All right, we have CH3, which is shell. CH3 is carbonate. You need to know that. You need to know the names of these. All of these names you're responsible for. So CH4 is methane. CO3 is carbonate. CO2 is carbon dioxide, and that's really it. That's like there's like 4 of them that you have to know, etc. Now the orange ones down here are our geosphere, okay, land geosphere. It's down there, okay, and this is where we get oil. So if there's oil down here, there could be veins of coal to be mined, okay, and that's because of all the dead things, and they get layered and squished over time, and we build up those reserves, right? Because if you can imagine how oil is created is because we have a grassy field, and then all the grass dies, more grass grows, it dies, more grass grows, dies, and you can see how a layering happens, and eventually there's enough weight, it starts pressing on all of the organic matter, and because organic matter is made of carbon, it turns into that black sludge, right, that you're seeing in your oil or in your coal in that rock form, okay? So that's kind of how oil forms. In a simple way, okay? Then bottom is the biosphere. So anything that's living, you're just going to draw green. That includes the fish, that includes the trees, that includes the cows, that includes the livestock, and importantly, it includes us, the people in this image. So what we're doing is we're just showing you how carbon can move around, right? So carbon can be exhaled by you or a building or trucks. It can be exhaled, and that carbon dioxide can be taken into plants. Actually, let me just back up and erase all this drawings here. Let me just draw it out. I'll make it a little bit bolder too. So we have us people, and we release carbon dioxide. Our trucks release carbon dioxide. Our buildings release carbon dioxide, and then that carbon dioxide can be taken by plants, and then the plants die, and they release carbon maybe into the ocean, like a log falls in the ocean, it gets buried, it gets broken down, and that carbon can be turned into a seashell. And then those seashells bury on the top of they get stuck here at the bottom of the seafloor, and they get layers and layers, and they get pressed into these veins of oil. And then that oil is brought back to the surface to fuel a truck or to power a building. And then it goes back into the carbon dioxide again. And then it goes into crops. And then these crops feed our cows. And then the cows fart out CH4. Do you see how there's this entanglement of how carbon just keeps moving through the environment? We're just tracking where it's going. And it's complex, right? And to do this, there's a fun game that we're going to play. Now, I say fun because this isn't fun. This is just taking notes. Anything's better than this. All you got to do is come talk to me, and I will give you the tools necessary to play this game. And what you're going to do is you're going to track what happens to your character. So if you start here in water, right, you're going to move to decomposers, and you'll move to sediment rock, and you'll go to vegetation, and you go back to sediment rock, and then you'll go become water again, and you'll go back. And if you stay there, just circle it. And then if you go to the next one, circle it. And then, if you stay there again, circle it. Then if you want to go here, you can go back, you can go there again. It should look something like this, and you should start to see patterns that form. Now, every time you stop at a place, I want you to write down what happens to you. And the game is going to teach you what happens in each of these things. So I want you to go and play this and do like 25 rounds. I want to see what happens to you as you like maneuver through the board and as you move around and what happens to you, okay? And you'll notice there's trends that form because a lot of times it goes back and forth, and every now and then you get stuck in fossil fuels forever because get trapped in the ground, or you get sit here and you're trapped in the ground again, okay? And so sometimes it's hard to get out of these places, sometimes it's easy to move around, okay, etc. All right, so I want you to play it. I want you to do like 25 rounds. Make sure that you hit most of these. I know sometimes if you play long enough, you still can't hit sediment and rock. It's okay. I just want you to track it out and become just familiar with carbon and how it moves, really. It's just giving you that experience, okay? All right, thanks for watching. If you have any questions, please come talk to me. This was a lot of information, but as you work through it, you may need to watch parts of it again. Pause it, rewind it, etc. Okay, thanks again for watching, and this is level 3, and this is the last unit, okay, of this, unit. This is the last level in the unit, so we're going to be preparing for our test, so please go back and make sure that you're reading and understanding the vocabulary. Know the vocab, okay? You're going to need to know these words for your test, okay, and the big concepts, okay? Okay, thanks for watching. Till next time.